This was a structure pop quiz 17. If you have a doubt, you can mention. Question number one, any doubt? One part A. Question one, part B. Any doubt? B1, 2. Okay. So B3. The maximum wavelength of a sound from a loudspeaker that can produce a stationary wave. So this is a closed pipe. Why it's a closed pipe? Because a pipe is closed from one end. So the maximum wavelength is when it is vibrating in a fundamental, which having a fundamental frequency. That's having a maximum wavelength. Because what will happen as the frequency increases, the wavelength will decrease. The maximum wavelength only happen or occur when it is a fundamental. So how you know it's a fundamental? Because we need the maximum wavelength here. So if it is vibrating with the fundamental, so we'll have antinode at the open end and we'll have node at the close end. Length of the pipe, we call that as a L. So what is this distance in terms of the wavelength? The distance between the node and the antinode is a quarter of the wavelength, lambda by 4. So we can say lambda by 4 is equals to L. So if we need the wavelength, it will be 4 times the L. So 4 times the length of the pipe. And how you know the length of the pipe? The length of the pipe is there in the previous part. So you just multiply by 4. So we'll know the maximum wavelength which can be produced. Because always the maximum wavelength is for the fundamental frequency, fundamental node. When it is vibrating with the minimum pattern, that is having the maximum wavelength. So after getting the length here in this part, you just have to multiply by 4. That will give us the maximum wavelength. Question 1, part C, any doubt? For those who joined the session, this is a structure pop quiz 17. If you have a doubt in question 1A, you can mention. Question 1B, 1, 2, and 3 I just discussed now. In case if you have a doubt, you can mention that. Part C, any doubt? 1 part C, C1, C2. Any doubt in question 1 part C1 and C2? No doubt. Question 2 part A, any doubt? 2A, 2B, 1 and 2. So actually for question B1, 2 and 3, for B1, 2 and 3, it is we have to represent the cylinder is having a length. A cylinder is there which is having a length of L. The resistance of the cylinders are the total number of the free electron or the charge carrier contained in the volume is N. N is the number of the charge carrier. Each electron carry a charge E. So charge of one electron is E or and can be represented by Q as well. The potential difference of the wire, like the difference of the potential is V. Determine the expressions in terms of some or all of the symbols E, L, N, R, V. So first, we need the current. What is the current? Current is charge divided by time. So if we need the current, current is charge divided by time. What about the charge? The value of, and what is the value of N? N is N is the total number of the charge. Capital N is how many charges are there, the total number of the charges. And V is the volume of this. Why not V equals IR? Because in the question, yeah, we can use V equals IR. That will give us the same result as well. I is equals to Q over T, or I can also use V is equals to IR. So I have the voltage, I use that. Where R is a resistance, that's also there, but we don't know the current. So if you need the current here, so the current will be V over R. So if you write this, that is fine. It's of one mark only. So the ratio between, yeah, we can work out, we can it's resolve this equation, but here it's of only one mark. So we simply use V equals IR. So if we need I, it will be the ratio between V and R, because it's V is there and R is there, so that's fine. What about the second one? The average speed of the electron, or the average disk speed of the electron. So which formula involved the drift speed? The formula which involved the drift speed, so we have the formula I is equals to the transport equation, or the current equation we can also say. So I is equals to N A V Q, where V is the drift speed. So if we need a drift speed, it will be I divided by N A. And what about this Q? Because I already mentioned this Q is the charge of one electron. We can replace that later. So V is equals to I divided by NaQ. What about I? Yeah, I'm solving now. What about I? I is the ratio between V over R. So in place of I can write V over R. So here I'm solving. In place of I, we can write V over R. What about N? N is the charge density. And how to work out the charge density? Because they mention that how many charges, N is the total number of the charges. N is the total number of the charges, and V will be the total volume. Like, let's say the total volume is V. So what is the value of N? The charge density, it's a because the term charge density means how many charges are present in a unit volume. So what about the value of N? Value of N is equals to N divided by V, where this V is a volume, not the voltage, it's the volume. So in place of N, I can write here, in place of N, I can write capital N, the total number of charges divided by total volume. Then we have the area. We don't know the area, so we have to cancel out the area. How to cancel out the area? What about the volume? Even we don't know the total volume. So if the cross-sectional area is A and the total length is L, so volume will be area multiplied by L. This V is a potential difference, but this V is a volume because N is called a charge density. So the charge density is number of the charges which are present in a unit volume. So this V in the denominator is not the voltage, it's the volume. Where this V is the voltage. The current is voltage divided by resistance. But the N is equals to number of the total number of charges divided by total volume. But we don't know the volume, so we can say N is equals to area multiplied by length. So in place of volume, I can write as area multiplied by length. So instead of writing volume, I will write area multiplied by length. And then it is multiplied by A, and Q is the charge of one electron, which is E. And this is a drift speed. So when we simplify, area will cancel with area. This L is a denominator of a denominator, so it will move in numerator. So we just have to simplify this equation now. So what we are left with? We are left with V L divided by R, because this R will be the denominator, so it will be R, N, and E. So the drift velocity is given by this formula. Is it clear, this one? The next we have the time, average time for these electrons to move along for the full length. So if we need the time, we already have these values. So either you can use a formula like speed is distance divided by time, or you can also use a formula for the current. So current is charge divided by time. If you need the time, so the time will be charge divided by current. What about the charge? Which is Q here. So if you want to know the total charge, you can multiply like N is a total number of charge carriers. And if I multiply by charge of one electron, I'll get the total charge. So I can say this will be N into E, because if I have I have a cylindrical wire and it is having these charges, the total number of charges are N. And each charge carry 1.6 exponent minus 19 coulomb, like each is E. So how many total charge will be there? So it will be the total number of the charges multiplied by charge of 1. I'll get the total charge. And what about the current? So we can drive this. We have current is equals to the first part, which was the ratio between voltage and resistance, so V over R. So if I simplify this equation, so it will be NRE divided by V. That will be the expression for the time. Is it clear, this one? Question 3, any doubts? Question 3, part A, which is related to diffraction and interference. So in question 3, student connected a signal generator. A student connects a signal generator to a loudspeaker. The student arranged a metal plates in front of a loudspeaker as shown. The student left the gap between the metal plates. The sound waves from the loudspeaker passes through the gaps. The gaps were approximately same size as the wavelength of a sound wave. The student stood at point X and he heard a loud sound. Why he will hear a loud sound? Because the first thing what will happen, the waves from the loudspeaker, the wavelength matches with the gap size, so it will have a maximum diffraction. So further diffraction will happen. And then the diffracted wave will interfere at point X. And why there is a maximum? Because the path difference is 0. That's why there is a maximum. Then as the student walked in a straight line in the direction of the arrow, as her position changed, the sound become quieter. So when she moved, the sound become quieter. So why the sound become quieter? Because a destructive interference will take place, or the path difference will be half of the wavelength. And then the sound become quieter and she heard no sound. And then as she further walked, what will happen again? The sound will be, there will be a maxima again. Because like minute, and the path difference will be one wavelength. So explain why the sound become quieter until there was no sound. So we just have to explain this idea. We don't have to explain the third part, only maxima and minima we have to explain. And it's of 6 marks. So how you'll score the 6 marks? And this answer should be structured answer. Like you relate, when we say structured answer, you relate one point with the next one. So what will happen when the waves will pass through the gap? The waves will diffract because, and it will be a maximum diffraction because the wavelength is approximately equals to gap size. That is one point. Then at point X, why we have a maxima here there? Because the two waves will interfere after diffraction. The two waves will interfere, and at point X, the part difference will be zero, or the phase difference. The part difference will be zero wavelength, or a there the waves will be in phase. That's why we'll observe a constructive interference or maxima. So 1 mark for diffraction, 1 mark that the two waves will have a part difference of zero or a phase difference of zero, and another mark that there will be a constructive interference at X. So as the student move away from X, like moving upward or in the direction as shown, the part difference will change. That's the fourth mark. As she moves, the part difference will change. Then the fifth point, that there will be a destructive interference, means the two waves will cancel out the effect of each other, and we'll observe a minima where the part difference is half of the wavelength. That's how you score all the 6 marks. So relating the position, the part difference, the in phase, anti phase, constructive and destructive interference. And as we move, the part difference will change. Now, same thing is try to, like student try to demonstrate with a lamp. A student connect two filament lamps to a same power supply. A screen is placed at a distance from the lamps as shown. Explain why it is not possible to create a consistent interference pattern on the screen using this arrangement. Remember one thing, that interference pattern is observable when the waves are highly coherent, like they have a constant phase relation. So light from the two lamps are, we are not using a laser light here, light from the two, because does it means? Like maybe first crest is coming out, next moment trough is coming out, next moment. So because the waves are produced from different places. So that's why the filament lamp never produces the coherent wave. So light from the two lamps is not coherent. So as a result, there is no constant part phase difference or the part difference. That's why we cannot observe the interference pattern, or even the wavelength or the frequency will not be same. Like some waves which are produced will have the filament is producing, no need for slits. It's not about the slits, it's about the pattern is not observed because the waves are not coherent. Because, and even the frequency, like some waves produced by the filament will have a higher frequency, some will have a shorter frequency or a longer wavelength. So even the like a filament lamp is also not only producing a light, even it's giving a range of the energy. So that's why it is not coherent or not a single wavelength. So you will score the 2 marks. You will score the 2 marks. One is for mentioning that the filament lamps are not producing a coherent source. The second is there is no constant phase relation. That's why it will be difficult to observe the interference pattern. Question 4, part A1, any doubt? For A1, A2? Suggest two reasons why the value calculated at A1 is a minimum efficiency that will operate the pump. So in the question, an irrigation system uses a pump to remove the water from a lower level to a higher level. Electricity for the pump is generated using the solar cells. The solar panel is 1.2 meter long and 0.8 meter wide, and the pump water from the lower level to a higher need for minimum 140 watts. calculate the minimum efficiency of the panel of of solar cell that will operate. Why we said that is a minimum efficiency? Because what will happen, like when these solar cells are placed, the incident light will not, because maximum efficiency when the incident light is 90 degree or perpendicular to the surface. But what will happen? The inclination, because the position of the sun throughout the day will change. So the angle will change. Angle at which the light is striking, that will change. So light from a sun will not be incident 90 degree, exactly 90 degree. It may be less than 90 or any value other than 90. So as a result, what will happen? The intensity or the incident light intensity will be lower. Second thing, the light which, so that is one thing. Another thing, what light strike the solar panel, it's not like all light will be absorbed. Some of the light will be reflected by the panel. So let's say 100 watt per meter square should, like, a power is there, input power is 100 watt, let's say. But when it strike, not all 100 will be absorbed by the solar panel, some will be reflected to the surrounding. Another thing, because we are used, so the electricity which is generated is used to transfer energy to the motor. So the motor might not be 100% efficient. There's a friction in the part, because mechanical systems always have friction. So the friction in the motor may lead to a loss of energy in the form of heat. That is one of the reason as well. Or even the light which is coming from the sun, this, because of the weather also it changes. Like if it's cloudy, then the amount of light which strike the solar panel, that will also change. So the input power, what we suggest, that because the intensity of a sunlight on the solar cell is 1040 watt per meter square. So, and this, why we call it a minimum efficiency, because lot of constraints are there, that this one, actually it might be higher than this, but what we receive on the surface is 1040 watt per meter square. So many reasons are there for having a lower efficiency when you are using a solar cell. The inclination, the angle at which it strike, not all the energy is absorbed by the solar cell. The when you use the system, the mechanical system which is linked with the solar cell, so efficiency of the system also affects the overall efficiency. Then in part B, light from a sun arriving at solar cell is unpolarized. You have to learn the definition of what is the difference between unpolarized light and the polarized light. So what is the meaning of the term unpolarized light? The unpolarized light has oscillation or vibration in, you can say, many planes. So a light which is having oscillation or vibration in many planes we call unpolarized light. Where light which is having oscillation or a vibration only in a, so unpolarized light is having light oscillation or vibration in many planes. What about the polarized light? The polarized light is having a vibration or oscillation in one plane only. Horizontal, vertical, or diagonal. And that plane include the direction of a travel. Like example, if a light is going in this way, there's also the direction of a travel also include that. So learn the standard definition of polarized and unpolarized light. Describe how student can demonstrate how a student can demonstrate that the light from a sun is unpolarized. So if you want to show that it is unpolarized light, so what we can do, say this is the light from the sun. which is unpolarized, and I use a polarizing filter which is horizontal polarized. So as a result, only horizontal component will pass through. Then when I rotate this polarizing filter, if I rotate this polarizing filter, I make it vertical, then what will happen? Only vertical component will pass. Horizontal will not pass, vertical will pass. So what we'll observe, if the light is unpolarized light and we are passing through the polarizing filter, always one of the component will pass through. So as always one of the component will pass through, so the intensity of the light which passes through will remain same. Even a polarizing filter is horizontal, even polarizing filter is diagonal. Like if I have a horizontal polarizing filter, I have a diagonal polarizing filter, I have the plane. Like plane is horizontal here, diagonal and vertical. So when I pass the unpolarized light, when I pass the unpolarized light, every time one of the component of the light will pass through. So as one of the component will pass through, so when I compare the intensity, all these intensities will be same. So that's how we can know that this is an unpolarized light. No, no. If they ask us, show that the light is polarized, then we'll use horizontal and vertical. Like if they ask us that show that the light is polarized light. So then what we will do, we'll use two polarizing filter. Initially, both of them are same plane. And then we rotate one of them, so there will be no light. So if there is no light, it means this light which was used is a polarized light. So to show that the light is polarized, we use two polarizing filter. First, they are parallel to each other, and then we rotate one from the other angle of a 90. The light intensity decreases to zero, and then we further again rotate 90. Again, the light intensity become maximum. The two polarizing filters are used to show that the light is a polarized light. But if we want to show light is unpolarized light, we use one only polarizing filter and we rotate at different orientations, but the amount of the light which passes through will not, intensity will decrease, but every time the amount of a light which passes through the polarizing filter will have the same intensity. Different planes, but the intensity will be same. So two polarizing filters are used to distinguish between the to identify it's a polarized light, and one polarizing filter alone, when you rotate, you can identify that the light is unpolarized light. Is it clear, this one? So this was a structure pop quiz. This was a structure pop quiz 17 related to topics electricity and the waves.